Learning target AST 1.4. I can represent the patterns linear, quadratic, inverse, and inverse square graphically, mathematically, in data tables, and in words. Okay. There are 4 types of graphs in this learning target. There are linear, quadratic, inverse, and inverse square. The first graph, linear, the equation for linear is y is equal to mx plus b. Quadratic's equation is y is equal to ax squared plus bx plus c. And the inverse is y is equal to k over x. And inverse square is y is equal to k over x squared. Now, inverse and inverse square are really similar actually, but the inverse graph is much more steeper than the inverse square. And as you can see, all the graphs are there for linear, quadratic, inverse, and inverse square. So, a quadratic function is any function that is equivalent to this equation. This equation is y is equal to ax squared plus bx plus c. If you see an equation or a function like this one, that means it has to be quadratic. These are some examples of a quadratic function. Y is equal to x squared minus 9. Now remember, not all cases will have a bx in them. In cases to be a quadratic function, you need to have the ax squared part. That's the most important part to define a quadratic function. Now, an ax squared plus bx plus c, using this equation, we can figure out that any of these equations match with this equation. So now we know that these equations are quadratic. Look at the equation y is equal to 3x squared plus 4x plus 3. Or y is equal to ax squared plus x plus 73. Or y is equal to 7x squared plus x plus 11. From these equations, from over here, I know this is my ax squared, I know this is my bx, and I know this is my c. Same with any of these equations. So, this is a linear equation. A linear equation is something that can be graphically represented by a straight line, such as this. This is a linear equation. This is a straight line, it's y is equal to mx plus b. These are like these are just sample equations of what a linear equation is. They're pretty simple. Y is equal to 3x plus 5, y is equal to 12x plus 11, and y is equal to 2x plus 4. The mx over here, so the m would be the 3, which is the coefficient, and x, and then b would be 5, 11, or 4, right? And then, I could graph it. It's pretty straightforward because it shouldn't be that hard to graph, and also it's, just a straight line. Oh, that's the... The question is, describe what is happening to the objects in this pictures. Okay, so now, let's look at this one. So what is happening to this graph in this picture? Okay, so I know this is a linear graph because I see a straight line as its graphical representation, and I know that that means the answer should be the object is going at constant velocity in a positive direction. So the object is going at constant velocity at a positive direction. Okay, that's the answer to this one. Now, Let's look at this one. Okay, from this picture, I'm seeing that the graph is accelerating. So, this should probably be a quadratic equation. Okay, so then that means the object is going at, that means the object is positively accelerating in a positive direction. So the object is going at a positive acceleration in a positive direction. The question is, describe what these objects are going through. Here are some more practice problems. The question is saying, describe what these objects are going through. Oops, let me just fix that. Okay. Now, this looks kind of weird. I remember in the last conversation that we had, a linear graph started from over here from 0 and ended up at a constant velocity over here. But here, I'm seeing the opposite. I'm seeing, instead of going in a positive direction, the linear graph, it's coming in a negative direction. So this object is going at a constant velocity, except it's going in a negative direction. So at constant velocity, but negative direction. Alright, now let's go to the next problem from this learning target. So this problem looks like something from the last problem that we just saw of the negative linear graph. So I'm seeing the same thing. So I'm seeing, obviously this is a different graph, but I'm seeing that this also is accelerating. I can see it's accelerating, yeah, I can say it's accelerating. But since I know this is a quadratic graph, I know it's accelerating in a negative direction. In a negative